So you are going to have 3D modeled problems where you've got multiple triangles in one, and you can use a combination of sine law, cosine law, and SOHCAHTOA to solve these triangles. So even just looking at this first one, this is our triangle that we're given, and we need to use what we've got from this triangle to find the height of it. So I would break this down if you've got colors, or if you just want to label and say, this is triangle 1, this is triangle 2, and this is triangle 3, right? Even though they all make one diagram, you can split this up into 3 different triangles are technically present here, right? Do we kind of see that? So, okay, starting first off, okay, I need to kind of figure out what's happening in triangle 3, specifically with angle C, if I'm going to find out what the height is here, because I don't have enough information in these triangles to determine the height. I have no side lengths. So I think we need to find this side length here in order for us to be able to do SOHCAHTOA with this triangle. So just starting off, can we find C? Yes. Yeah, how can we find it? We've got the 2 other angles, so how can I find angle C? Yeah, 180 minus 43 minus 58. And this should give you 79 degrees. Right, so okay, we've got that down. Step 2, right? We need to find this side length, B, I'll call it. Right? Because we don't know that. I need a side length in this triangle since I've got an angle and I need the height. So like the goal should be I need to find some side length in this triangle in order to be able to find that height. So I need to solve this one first. So to find that side length, I'm going to just draw that triangle on its own, right? For start. So just a quick little sketch of it just so I can see it by itself, not distracting. So we know this is C and we determine this is 79 degrees. This is A, which is 43 degrees. This is B, and this is 58 degrees, and we know that this is 225 meters. If we want to know what this is, you could use sine law. You could use, we can't use cosine law because I don't have all of the side lengths, so by a process of elimination, I gotta use sine law. So if I'm looking for my pairs, I'm like, okay, this is a pair that I need to find, and then this is a given pair. I've got an angle and a side length that match. So that's good. So, okay, if I'm doing sine law, I'm going to say B, the side length is my unknown. That's going in the numerator. So B over sine B is equal to C over sine C. And we're just going to fill in the information we know. B is unknown, so it stays B. But I have its angle. That's 58. And then C is 225. All over sine 79, which if I want to get rid of this denominator, I got to times both sides by it. Right, so that's going to leave me with B is equal to, right, if you want to draw this here or write this here, you can. So that cancels out. This is going to be 225 sine 58 all over sine 79. Which I get approximately, if we're going to do 1 decimal point, 194.4 meters. Do you concur? Yes, you concur? You agree with me? Okay, cool. So now we know that side length, right? So now I can finally draw, if I'm going to be able to write there, this triangle on its own, that little right angle triangle. So I can draw it here where it looks like that, where I know, okay, this is my right angle, which is coming from point C. This is my angle A, which is 29 degrees. And this is my angle, or my point D, I should say. And this is my height that I don't know. But now we know the side length. We know that this is 194.4. So I've got enough to do SOHCAHTOA, which looking at from my angle, I've got the opposite side length, which is our height, and I have the adjacent side length, which is the 194.4. So which trig ratio can I use for that? Opposite and adjacent. Yeah. So yeah, I was gonna say go through SOHCAHTOA. SOHCAHTOA. Opposite adjacent, OA, so that's tan. So we can use tan. We're gonna do tan 29 degrees is equal to opposite H over adjacent 194.4, which again, you want to get rid of a fraction, times both sides by the denominator. So it's like we're timesing both sides by 194.4. So that will cancel out here. H goes by itself. So I want to go back to blue. 194.4 tan 29, that will be equal to H, which if you plop that into your calculator, and you can agree with me, I got 107.8 for H, approximately. Do we get the same thing? Mm-hmm. So therefore we can say the height of the triangle is 107.8 meters. Big triangle. Right? So sometimes with the 3D models, you have to dissect it into multiple triangles and solve parts of them individually in order to build off on the other triangles, right? So like, for example, these two triangles share B. They share the side length. So that's why we used both of them in order to determine the height, right? Even in triangle 2, if I said find the height, that would be way too easy because this is the height. You could just use SOHCAHTOA normally. Yeah?
But we don't know if we can use SOHCAHTOA because there's no right angle symbol there. Or should we just assume? Okay.
You can assume this one because they're coming together, right, at this right angle. So with this one, if I asked you to find the height, that'd be way too easy. But what if I said I want you to find this side length? I want you to find BC, right? How could we find the distance between B and C based on what we have, right? Yeah, so it's like, okay, if I need to start finding something in this side length, I would think about what side lengths does this triangle share with, right? It shares this side length and this side length here. So I should probably go about solving these triangles and figuring out their bases in order to determine what's happening in this triangle. So again, I'm gonna label them. We're gonna call this one triangle 1, this one 2, and this one 3. If you want to use colors and color them individually, you can also do that, whatever floats your boat. Right? So, okay, if I'm thinking about this, they share this side length. Let's call that one X, right? That's a side length that those two triangles share. So I need to find the base of this right angled triangle. So for this one, we're going to use triangle 1. So use triangle 1. Because it's right angle, it's SOHCAHTOA, so I can even draw like a little sketch of it just to include it. And I'll say, okay, if this is 20 degrees, this is my X, this is B, A, and D, and I know this is 10. To find X, okay, I've got its adjacent side length, and I have the hypotenuse. So I've got A. So am I going to use sine, cosine, tan? I'm going to use cosine. Adjacent over hypotenuse. So, okay, cos 20 is equal to adjacent x all over hypotenuse 10, which, lucky for us, 10's on the bottom. We're just going to multiply both sides by 10 to get rid of it from the denominator. So it cancels out. And we're left with 10 cos 20 is going to give me x, that side length, which I get approximately 9.4. If you agree. Do we get the same thing?
Yeah.
Cool. So that's done. I know this side length now, right? So you can replace it with that in the diagram. I also need this side length because this is something that they share. So I'm going to call this one y, right? And we're going to find y. So, okay, now I'm going to use triangle 2, which I'll label up here. Oh, I need space. So I'll do number 2. Use triangle number 2. Which, same dealio, I'm going to draw its little diagram so I can kind of just isolate it on its own and see what I need to solve. This is y, this is 40 degrees, that's C, this is my A, and this is 9, which, same thing. It looks like I've got adjacent and hypotenuse, so I can use cos again, right? But just slightly different measurements. So this is going to be cos 40 is equal to adjacent y all over hypotenuse 9. And I times both sides by 9 to get rid of this fraction. So 9 cos 40 should give me y. which I get 6.9. Right? So not bad, SOHCAHTOA, nothing too complicated. Now it's like, okay, because I now have these two side lengths, and I have the corresponding angle for the missing side length, I can use cosine law for this, right? So if I want to use now triangle 3, I can see from my little sketch, which I'll scooch it over a little bit to save room. All right, this is 100, and this is at D. This is 9.4. This is 6.9, B and C, and this is my unknown. So it's like I've got the two other side lengths, and I've got the corresponding angle for this missing side length. I can use cosine law. Right, so we know that we'll call this one, we can call it just D, little lowercase d. So we know that D squared is going to be equal to 9.4 squared plus 6.9 squared. I hope I have enough room for this. Oh, this should be fine. Minus 2 times 9.4 times 6.9, and then cos 100. Right? That's your cosine law. Which we remember from grade 10, and we watched the video of it that I posted for 5.7 when I was away. No? You gotta review it. There is a video posted. There's nothing new to cosine law for grade 11. So if you watch the video, you will see it's just same practice problems like from grade 10. You're just using the same formula. There's no step up. There's no ambiguous case for cosine law. It's just regular cosine law from grade 10. That's it. So, okay, when you pop this all into your calculator, because you can do it all in one shot, you will get that D squared is equal to 158.5, about. Right, approximately. And to undo this square, we square root both sides. So D is going to be equal to the square root of 158.5, which will give you approximately, I got 12.6. Right, so therefore, we can say BC is equal to 12.6 meters. Or we don't even have units in this case, so I'll just say units. Right, so we had to use all three triangles and a mixture of SOHCAHTOA and cosine law. I couldn't have used sine law for the bottom triangle because I don't have any angles in there to match it with. I don't have any pairs. So that's why you have to assess what you have, right? The side, angle, angle, side, that whole chart. That's what's helpful. Right, so now we're going to do a couple problems, real life scenario, and I want you to do the last one on your own. So we're going to work up to it, so don't worry. Right, so for example, this one's talking about a cliff, and it says from point B, so this guy, this is Manny. Manny is using a clinometer to determine the angle of elevation to the top of a cliff, and he determines that it's 38 degrees from where he's standing. From point D, 68.5 meters away from Manny, Joe, so this is Joe over here, if you want to label it. Joe estimates the angle between the base of the cliff himself and Manny to be 42 degrees, while Manny estimates that the angle between the base of the cliff himself and Joe is 63. And it says, what is the height of this cliff? So from this scenario, we have produced two triangles, one of them being a right angle. The bottom one is not a right angle one. So, okay, even just looking at the first triangle, right? And we can call this, again, 1 and 2, or you can use colors, whatever floats your boat. I'm going to say, okay, let's look at use triangle 1. Let's do that. I've got some information missing from it that would probably help me solve. Yeah, probably, I would say. That would be helpful. And I have to also look at my diagram and see, okay, and this is 68.5, and that's all we know. This is C, this is B, and this is D. If I'm trying to solve this triangle, again, the goal is like you're looking at what side length do they share, because that is the thing that you need to solve for. I don't really care about this side length necessarily. I care about this side length because this is attached to this triangle. That's the thing that I need. So that should be my priority. But like Lucas said, we kind of need to find this angle first, which is not too bad. We have the other two angles in order for me to be able to do sine law potentially to find it. So, okay, side or angle C, we've got my two other angles, so I can just do 180 minus both of them. What'd you say it is? I agree. So 75. So I'm going to write that in pink since we added it. 75 degrees. Now that I have it, okay, I can't really do cosine law because I don't have all of the side lengths, but I could do sine law, right? I have a angle and a matching side length, and this is our unknown. CB is the side length that's attached to the other triangle, see? So that's the thing that I need to find. So this will be my other pair in pink, the 42 and then the unknown B. Those will be my pair. So, okay. It's going to be B over sine B, or did we call it B? This is D. Pardon, D. I flipped it. B would be this side because it's from the corresponding angle. My bad. So D, opposite side, over sine D. And then we used C as our pair, so C over sine C. And then we input what we know. So we don't know D, but we know its angle, so that's 42. So D over sine 42. And then we know everything about C. So C is 68.5, and then its angle is going to be 75. Hold on. What do I do next? Sine 42. It's got to go. We need it out of the denominator. So, oops, sine 42. So that cancels that out. So I'm left with D equals 68.5 times sine 42 all over sine 75. And so big calculations, but I get approximately, I'm going to leave it to like 2 decimal places because it's like a 47.45, but then I think the third one's like a 2. So it's like 44. So 47.4. I'll even leave it as 2, round it to 5, because the next decimal is big, right? Because you would round it up, right?
Wait, hold on.
Yeah, you could leave it as 2 decimal places.
No, it's 47.45.
Yeah, 4 or 5, and then just leave it. Like it wouldn't round up to 46, you would just leave it. Let's keep it exact. So, okay, that's this side length here. Which then, okay, since I've got that, I can write this in this diagram now that I know it. So we're going to say 47.45. And now I can use triangle 2 to solve. So 2. Use triangle 2. Number 2. And that's my right angle triangle. This is A. This is my height. This is C and B. My angle from Manny's 38. We determined this length is now 47.45, and that's all the information we have, and it's a 90. So, okay, I've got opposite from the angle, and I've got adjacent with the angle. I can use tan, yep. So, okay, we're going to do tan 38 is equal to opposite H over adjacent 47.45, which we're just going to times both sides by 47.45. Right, cancels out, H is by itself, so 47.45 times tan 38. And that should give you about 37.1 meters. Right, so that is going to be the height of our cliff. The height of the cliff. The cliff is approx 37.1 meters. So that's it. Just combining and splitting your triangles, yeah? How do we feel about these so far? Are they okay? They're not bad, right? Okay. What if you have to draw the diagram?
Wait, sorry.
Yep.
What did you get the last one?
37.1. 37.1. Am I okay to flip to the next one? Are we okay to flip? Am I good over here to flip or a couple seconds? Okay, okay. So with this one, I give you the description, but you need to draw the diagram. It's always going to model that same like 3 triangle diagram, right? So that's what we can kind of think of. But this is talking about an airport tower, and it's saying the airport tower is 30 meters tall. Some distance away in the southeastern direction, airplane 1 is parked and has an angle of elevation of 20 degrees from the nose to the top of the plane. And then same thing in the southwestern direction, airplane 2 is parked and it has an angle of elevation of 50 degrees. And so it says the angle between airplane 2, the tower, and airplane 1 is 40. So we want to know what's the distance between them. Solve this without a diagram. You're superhuman. I have to visualize this. So I'm going to start with a diagram and see like, okay, what does this even look like? I know that it's always going to model this 2 triangle, like 2 right triangle base. It doesn't look like a right triangle because it's slanted, but it is right triangles. Or you have then a 3rd triangle on the base. Right, so this is our point. This is our tower, which is going to be 30 meters tall. Right, so I'll call this like T for tower. Right? And then we said in the southeastern direction, this is plane 1, or you can call it P1, whichever one you want. And it's got the angle of elevation from the nose of the plane to the top of the tower, which is 20 degrees. And same thing, plane 2 is in the southwestern direction. So this is plane 2, and it's got an angle of elevation of 50 degrees. Right, these are right angle triangles. And then the last bit of information that it gave was from plane 2 to the tower to plane 1 is 40 degrees. So that means that this middle angle here is 40. Right? That's all the information it gave us. Is that okay how we drew the diagram? Or is there anything you want to clarify why it is the way it is? No, she's pretty to you? Okay. Cool. We want to know this. How far apart are the planes? We don't know how far apart or how far parked away they are from each other. So again, I got to dissect my triangles. I got to work with them. If I'm trying to find something in this triangle, it would probably benefit me to find these side lengths since they are shared with that triangle. So like, why don't we do the same thing again where we say, okay, let's call this X, let's call this Y. We'll find those bases and then figure out the distance. Does that sound cool? Okay. So it doesn't matter which triangle you start with. Again, I'm going to call this 1, 2, or 1, 2, and 3. And I'm going to just start with triangle 1. So use triangle 1. Same dealio. If I do my little sketch of it, which I find doing their little individual sketches is nice because sometimes trying to figure out things while it's in this big diagram gets kind of confusing and messy. So I always do just a quick little sketch of it on its own and say, okay, this is 50 degrees. This is my X that I'm trying to find. This is my P2, my plane 2. This is my tower, and this is 30 meters. And we'll call this just B for base. That's the base of the tower. What information do I got here? Tan? Why tan?
It's opposite and adjacent.
Right? So, okay, I can use tan based on the information I got. So tan 50. But this is going to give me opposite 30 over X. Ugly. Unknowns in the denominator. Yeah, exactly. You can flip, or if you go to do the same process of, oh, we don't want this fraction, I'm going to multiply both sides by the denominator. You will just notice that you have to do a little extra step because you have this X tan 50 is equal to 30. So to finally isolate X, you just have to divide both sides by tan 50. So x is going to be equal to 30 over tan 50, which you should get, and I got 25.2. 25.2 meters. So, okay, that's the distance from plane 2 to the tower. That's fine. We got that. Okay. Then I can use my second triangle. Use triangle 2. And I can find the distance from plane 1 to the tower. So, okay, that's just a flipped right angle triangle going the opposite direction. But same information of like, this is T, this is the base, this is now plane 1. This is still 30 because that's the height of the tower. That has not changed. The only thing that's different is the angle of elevation. That's going to be 20. And we said that this is y, so we need to find that distance, which you'll see, you can just use tan again because you still only have the opposite and the adjacent. So, okay, tan 20 is equal to opposite over adjacent. You encounter the same thing where the unknown's in the denominator. So again, you can multiply both sides by it. You'll just have to do the extra step of dividing tan out. So y times tan 20 equals 30, or y is going to be equal to 30 over tan 20, which I end up getting is 82.4. Do you get the same thing? We're okay? All this? Okay, you've got your two distances. Your third triangle is now the big one that's on the base. So we can say, okay, step 3, which I'll do some stuff over here just to space it out. We'll say, okay, here's our triangle. That's the base. Okay, we've got P2, P1, and our base. We said that this was 40 degrees because that was given. We know that this is 25.2 because that was what we solved for. That was our x. And then our y was 82.4. 82.4. And this is our unknown. We do not know the distance between the planes, which, what can I do here? Yeah? Cosine law, exactly. Because I don't have any interior angles, so I can't do sine law. So, okay, we're going to say, we'll call this like b, if we want to call it like little lowercase b for base, or if you want to call it d for distance, whatever you want to call it. We'll call it d for distance. I'll say that. D for distance. So we'll say, okay, d squared is equal to my two side lengths squared, so 25.2 squared plus 82.4 squared minus 2 times both my side lengths. Ooh, 82.4. And then cos whatever the angle is given, so cos 40. Which the calculator can do the heavy lifting. You can do that all in one shot. I end up getting approximately 4,258.66-ish. And again, to undo the square, use square root. So you'll see this process, while it's tedious, it's very repetitive. So even if your diagram changes, you're still doing the same processes over and over again. The only thing that will change is your values, or maybe what they're requesting you to find. Right? So I get approximately 65.3. Do you get the same thing? No? What do you get? 42, 43?
Yeah, I got that.
You got that as well? Where's my calculator? This is why we fact check. Where's mine?
I got 65.3.
You got 65.3. Square root of 4,258.66. I get 65.25 or 65.25. So fix 65.3.
Yeah, for the
Under the square root.
For under the square root,
42.3.
I get 25.2 squared plus 82.4. Ooh, delete 4 squared minus 2 times 25.2 times 82.4 cos 40. 4243. Yeah. Okay, let me check. 4243.44 or 0.45 if we're going to round. Ah. This is why it's always important to fact check. Thank you. Okay, so close. So it was 4243.45 approximately, which then the square root of that is 65.1. So 4243.45, and that was approximately 65.1. There we go. So therefore, the planes are 65.1 meters apart. Voila. So now you've seen the process of how to set up these problems and how to solve. I would like you to try this one. It's the same thing. You can use the boards around you, but it's the same idea of you have somebody standing on a platform, a diving platform, and you have two people to both sides of him, his parents and his coach. And both of them are looking up at him at an angle of elevation. So you have the angles there. What you want to find is how far apart are his parents and the coach, right? So try to build the diagram, solve it, and then see if you can find how far apart are his parents and the coach. All right, so okay, peeps, are we good? So for the recording, because I just recorded it now, we always have this diagram where you've got the two right angle triangles forming side by side, which then produces a third triangle as its base. That's always happening. Here's Jeff at the top, and he's on this 10-meter diving board, or like that's how far he's gone up on this platform. And it says to his left, right, his coach is here. So we'll put C for coach. And then to his right are his parents. Right? It says his coach is looking at him from an angle of 37 degrees versus his parents are looking up at him at an angle of elevation of 32. So those are his parents. It's always with the right angle triangles, not the base of the triangle, because that's looking down. It's from parent looking up, right? If you picked this angle, this would be the degree that the parents are looking at, like the base of the diving board. But it's his left. So you're imagining him looking this way down at them, right? I think you still find the right answer, regardless, as long as your triangle measurements are correct. So it doesn't matter if it's your right or his right, whatever, it works out. But technically, this is his left and his right if he's looking down at them. We want to know this distance. How far away are his parents and his coach? So someone walk me through. What was the first thing that you did? Oh, and we said that their distance between them, their angle between them is 100. What's first thing? Yeah, Ryan? Yes, you can use the washroom. Does somebody else want to tell me the first thing that they did? What happened? What did you do?
The triangle on the left.
Okay, so you called like what? This one triangle 1,
Yeah.
this one 2, and this one 3. So Kian did first triangle 1. So use triangle 1. And what did you find in this triangle?
I used the tan ratio and I found the angle that connects to triangle 3. I mean, the side that connects to triangle 3.
Okay, so from his parents to him and then to like the base, you found this one, which I can call X. Cool. And so you said it was tan?
Yeah.
So tan 32 equals what?
Tan over X.
Tan over X, which then, what do I do?
Multiply both sides by X.
People, don't you want to see if this is right? Okay, and then I got to isolate X, so I got to divide by tan 32. And what did you get when I do 10 divided by tan 32? 13.3. Cool. Okay. So now I know that one. What's next? What else do I need to find? So we found this guy. This is 13.3 in the triangle. What else do I gotta find? Same thing, but the other side. So like this guy, right? So, okay, use triangle 2, which is the other right angle triangle. We still know that this height is 10. This is now going to be 37 degrees, and we don't know this guy. So, okay, can I use the same tan ratio? Yeah. So same thing, tan 37 is going to be 10 over y, which in this case, from isolating so much, you'll know that y is just going to be equal to 10 divided by tan 37. You're basically just flipping spots with tan and y. Which then, what does y equal? I got 16. Ooh. 16.
Yeah.
Yeah, it was like 16.00 something, so just approximately 16. Okay, cool. And then we said 16 and 13.3. Okay, and then last step, we need the base of this triangle. So we don't know this. We know this angle is 100. And we've got parent and coach. And we know that this is 13.3. And we know that this is 16. Okay. And now we need this distance. What can I use for this? Cosine law. So, okay, we'll call it like d again for distance. So d squared is equal to my two side lengths squared and added together, minus 2 times both my side lengths, and cos of whatever the angle is, so cos 100. Which, okay, correct me, since I messed up the last one. I got 506.8. Okay. And then I had to square root to isolate d by itself. So the square root of 506.8, which I got was 22.5. Voila, so therefore, his coach, yeah?
For the first one, for X, I got 16 for that, and for triangle 2, I got 13.
It just depends where you put his parents and his coach. Because in the question it says, to Jeff's left, that's his coach, and then to his right is his parents. Where some people might go, but this is my left and my right, and then they switch these. So it's okay. It just depends on your labeling, right? And who you chose, who's left and who's right you chose. So as long as your dimensions are the same, that's fine, right? You'll get the correct answer that they are 22.5 meters apart. Voila. That is it. So that is three-dimensional problems with triangles. You've got some practice problems, which I will flip back to that page. Try. Otherwise, if you need some time to finish your assignment, now's your extra time, because we got like about 15 extra minutes, 17 minutes. So if you need to finish up and submit, you can use that time now, or you can work on practice problems. And I will give you review for your test next week. Cool? Cool.